you by thesis123.com. I learn and teach online.
Here's the next question, number 51. A single phase transmission line has two conductors each of 10 mm radius. These are fixed at a center to center distance of 1 meter in a horizontal plane. This is now converted into a three-phase transmission line by introducing a third conductor of the same radius. This conductor is fixed at an equal distance d from the two single-phase conductors. The three-phase line is fully transposed. The positive sequence inductance per phase of the three-phase system is to be 5% more than that of the inductance per conductor of the single-phase system. The distance d in meters is dash. Okay, so let's try to visualize how this turns out. So a single-phase transmission line has two conductors. So let's call these two as our two conductors A and B, and the distance between them center to center is 1 meter. Let's call the distance as d1, and the radius of each of these two conductors is 10 mm. 10 mm radius, distance of 1 meter in the horizontal plane. Now we have a third conductor added to the mix. So when the third conductor is added, the distance between them is d, equal distance d. So let's call this d2 and d3. So we have d2 and d3 with the distance value of d. We are supposed to find out how much this d is. So the first thing is, let's find out what the inductance of the conductor is. That's per phase. Since we have here three phase, we will have to calculate per phase. So inductance of, now we're going to start with the first conductor. So the inductance of A, conductor A. Conductor A, this is phase. We have to remember this is the first phase, per phase. So L1 is equal to, so we will have to use the formula for the inductance of conductor per phase. That's 2 into 10 power minus 7 ln of d by r dash. R dash is the geometric mean distance, geometric mean radius of the conductor, and geometric mean radius is given as 0.7788 r. R is the radius that is given to us, and r dash is the geometric mean of the entire term. So let's substitute the value for d here. D is 1 meter. So 2 into 10 power minus 7 ln of 1 divided by 0.7788 into 10 power minus 3, since it is millimeter. Okay, so if we solve this, let me just get another sheet here. If we solve that, we get a value of L1 is equal to 0.97 microhenry per meter. Okay. Next, we need to find out what L2 is. That is the inductance of the conductor of B, the second inductance for this conductor here. Now the question says that it is 5% more. So 5% more than L1. That gives us 1.05, 5% more into 0.97. That gives us 1.0185 microhenry per meter. Okay. Now that we have a value for L2, we can use the same value in order to determine what D is. So the next thing is that dm, that is the total distance for a single circuit, a single three-phase circuit, can be represented in the form d1, d2, d3 to the power of 1 by 3. This is a formula that you have to remember. Okay, so now L2 can be written as 2 into 10 power minus 7 ln of dm by r dash. So dm is the total distance, or the distance for a single circuit, a three-phase circuit. Now since we have 3 conductors, we need to find out the distance d. So that's what we are going to introduce over here. So that's 2 into 10 power minus 7 ln of dm by r dash. We have already found out what L2 is, so we substitute this here. dm is this, so let's write that 2 into 10 power minus 7 ln of dm is this, so that's cube root of d1, that's 1 meter, d2 and d3 are both d, so that becomes d square, divided by 0.7788 r. So this is our expression. Now let's substitute our values. We get 2 into 10 power minus 7 ln of cube root d square divided by 0.7788 into 10 power minus 2. I write 10 power minus 2 because the radius is 10 into 10 power minus 3. So that would be 10 power minus 2. Okay. Now let's substitute the value for L2 here. L2 is 1.0185 into 10 power minus 6 is equal to 2 into 10 power minus 7 ln of cube root d square divided by 0.7788 into 10 power minus 2. Now once you solve this for d, you will be able to find the value for d. Now I will leave that part to you. All you have to do is bring 2 into 10 power minus 7 down here. That becomes, you will have to divide, which would be equal to ln of this, and in order to eliminate the logarithm term, you will have to raise it to the exponent e. I think I'll just show that part to you. So we have here 1.0185 into 10 power minus 6 is equal to 2 into 10 power minus 7 ln of cube root d square divided by 0.7788 into 10 power minus 2. Okay, so the first thing we can do to simplify this is 1.0185 into 10 power minus 6, take this down here, 2 into 10 power minus 7 is equal to ln of the rest, cube root d square divided by 7788 into 10 power minus 2. Now in order to take it, eliminate the ln term, it would become e power 1.0185 into 10 power minus 6 divided by 2 into 10 power minus 7 is equal to d square divided by 0.7788 into 10 power minus 2. You can cross multiply, you will get 0.7788 into 10 power minus 2 e to the power of this entire term 1.0185 into 10 power minus 6 divided by 2 into 10 power minus 7. I hope this is visible to you all, is equal to cube root of d square. I'll just write this down here very clearly. 0.7788 into 10 to the power minus 2. Make sure that you solve each of these terms first. e power 1.0185 into 10 power minus 6 divided by 2 into 10 power minus 7 is equal to d to the power 2 by 3. Now in order to find d, first you solve this entire part, and once you are done, you have to cube root it. Since it is 2 by 3, first you have to cube it and then take the square root of the term. Once you do that, you will find your value of d is equal to 1.427 meters. I'll leave that part to you, but just solve it and try and check. Your value should match 1.427. So this is the final answer. That would be 1.427. I hope this helps.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.